Okay, we'll pick up where we left off. Virtual reality. In the early days of quantum mechanics, again the 1920s, there were quite a few of those physicists who thought that information was key and this might be a virtual reality. Matter of fact, one of them, John Wheeler, he was one of the young guys back then, and he coined a phrase called "it from bit." I don't know if you've heard that, but that's Wheeler's phrase, and it means everything, the universe, from bits, from information. So that was an idea then that was current and exciting. About a decade, actually a little more, just a few years more than a decade, when I was writing these books. Actually, I finished writing them in 2002, and when I did a little literature search. I always do literature searches after I'm done something rather than before I start. And after I was done, I did a literature search to see about virtual reality. Anybody else out there agree with me or not? And I came up with 3 guys who did. And one of them, Edward Fredkin, in 1992, he published 2 papers that talked about why he was sure this was a virtual reality. And within probably 3 or 4 years after that, not very long, there was a new branch of physics born called digital physics. And there are digital physicists who practice digital physics all over the world. So there are hundreds and hundreds of physicists who are digital physicists. So that kind of started it. Then there was Nick Bostrom, who's a professor at Oxford now. He wrote a paper, "Are You Living in a Computer Simulation?" And as he went through, he was a philosophy. I think he had some physics background, but he was really a philosopher. So he looked at the philosophy, the logic of it, looking at it logically. What's the probability that we're in a virtual reality? And his conclusion was, it's very likely that we're in a virtual reality. And then last, it was Brian Whitworth. And Brian Whitworth was working more currently. He's the last in this lineup. And Brian is a computer scientist, mathematician, more than he is a physicist. But he came to the conclusion that it was a virtual reality and said, well, let's just test it. Let's see how the 2 different views of reality, describe the data. So let's take a look at all the stuff we know in science, all the stuff we know in physics, and then let's say with the assumption of a virtual reality, how does that explain it? And with the assumption of we don't know, it just exists, which is basically the way materialism is, can we explain it that way? In other words, the material world just is. That's the alternative. So he did that. He took the standard, it is material, and the virtual reality, he made a big matrix, and then he took all the various facts we know, put those down the vertical side, and then they had the 2 different assumptions, and then he checked the boxes and wrote inside which one actually covered the known facts best. And when he was done, he was completely convinced that this was a virtual reality because it was much better. It explained much more of the facts if you base it on a virtual reality than if you base it on a materialist objective reality. So that convinced him, and he did a lot of detail. And since he's done a lot of work in looking at how computer science, how in a computer, digital computer, you could create the kind of fundamental things that we have in this reality, like mass, force, gravity, and so on. And he's been very successful with that. But so Edward Fredkin was in the 1990s, early. Brian Whitworth was just in the last 5, 6 years, 7 years. And as far as I knew at that time, we were the only 3 people in the universe that thought that virtual reality was a really good idea and made sense. Okay, it was way out there on the fringe. Now, in 2002, a decade later, that wasn't the case. In 2012, a decade later, that wasn't the case. in 2015, you can find digital physics and virtual reality are very serious, they're accepted very seriously. They're not out on the fringe anymore. They're mainstream ideas now. You can find panels in physics colloquium that are digital physics panels and virtual reality panels, and all the big guns from the big name universities are all there, all talking about virtual reality. So it's becoming, 1 decade isn't much for that kind of a swing. So what's happened is, and why they've changed, what happened to the denial that we saw earlier, what's happening is that the experiments that they do can't be answered any other way. If you want to explain the data of the experiment, virtual reality is the only way to explain it. And indeed, physicists today don't talk about an electron as a little chunk of mass with a charge. They say that's old thing. An electron is a point with the properties of mass and the properties of charge, which is exactly how one would model an electron in a computer. It would be a point with those characteristics, those properties. And if they think of it that way, then they can understand their experiments. If they don't think of it that way, if they think of it as a little chunk of mass with a charge, they can't understand their experiments. So this idea that particles aren't really particles, they're probability, and this idea that reality is virtual is finally beginning to sink in, and the spider web of experimentation is giving them less and less room to deny it. So it's getting more and more popular. I suspect in another decade it will probably be a dominant viewpoint in physics, that this is a virtual reality. You have to realize that's a big state change. You see, as soon as you say this is a virtual reality, somebody's going to say, who's the programmer? Where's it made? Because as Friedkin said, a virtual reality has to be computed in other. A simulation cannot compute itself. A simulation has to be computed outside of the reality frame that it computes. Okay, so an example would be if you're familiar with the World of Warcraft. That's a game that kids play, boy kids particularly. My boy kids, got carried away with it, but anyway, it's a game where you have elves and barbarians and other things, and they go with multiplayers from all over the world are playing these characters, and they go interact and do things. Of course, as little boys, they tend to fight, right? It's what they do. But we can excuse that for a moment and say they just are characters and they interact. Okay, that's the World of Warcraft. Now, what Friedkin was saying is that the server, the computer that creates that virtual reality, World of Warcraft, okay, the elves and the barbarians and the rivers and the rocks and the trees and the mountains and the sky and all that stuff that's in that virtual reality, the computer that creates that can't be a part of that reality. It has to be non-physical to that reality. So if you're the elf, that reality is physical, right? The elf sees that virtual reality as physical. It can't walk through the trees. It falls off a cliff, it gets hurt, it gets underwater, it drowns, that's its physical reality. And the computer must be someplace else. Well, Friedkin called that other. It has to be computed in other. That means other than here. So if we're in a virtual reality, it's computed in other. So see, that's what I mean by it's a big C state. If the scientists who, in my opinion, they are the high priests of Western culture. By that, I mean the high priests tell everybody else what's true. They tell us what to believe. And now that's the physicists or the scientists. They tell us what's true. If the scientists say this is the way it is and it's true, everybody else nods their head and says, yea, verily, that's true. The scientists say this is a virtual reality and it's computed in other. You've just opened up a huge interest from non-scientists of where is this other, who's the programmer kind of thing. So that's why I say it's a big deal, not only within science, but this is a big deal in people in general. societies, people, this is going to be a much bigger than the world being round instead of flat, much bigger than Newton, in his mechanistic universe, much bigger than quantum physics and relativity all put together and multiplied by 10. This is going to be a very big change that hits the culture, and that's one of the reasons that physicists don't want to go there. That's not the territory that they thrive in. They thrive in a material, objective world where they're the only ones that really know what they're doing. This would kind of include everybody. This includes metaphysics and philosophy and theology, and they're getting into all these fields, and they don't want to be in all those fields. So that's part of the reason why it's like, don't take me there. Okay, but that's where honest science takes you. And there are enough honest scientists that when it says that it's virtual, they go there, but they really don't like the logical implications. So they go there kicking and screaming, as they're drugged by their experiments. It's not something they want to do. All right. Okay. As it turns out, I'm going to take a jump now out of science for a while. As it turns out, consciousness is the fundamental reality. Okay? The larger consciousness system is a digital information system. Okay? At the most fundamental level, consciousness is awareness, and awareness is information. Okay? What are we conscious of? What is our consciousness telling us now? Well, for you, it's telling you that I'm up here talking and we got the screen lit up and all of that. Well, what is all that? It's data. Data goes into your eye and your ear, hits a nerve, sends little impulses, electrical impulses down those nerves, and neurons scatter and go places and, do memory. Well, what's all that? It's just information. So we have these 5 senses, and they are the information gatherers. The information comes to us, and we, as consciousness, interpret it. Okay? We interpret the data. When you're playing World of Warcraft, you have a flat surface in front of you with 1 million or so pixels on it. Each one has a certain brightness, a certain color. That's it. It's just a whole bunch of little dots of light. You take in all those little dots of light and you interpret the World of Warcraft and what's going on there and all the action. You interpret that data. So consciousness is awareness. Awareness is information. What are you aware of? You're aware of what you get information about. So you see, describing consciousness as an information system isn't as crazy as it first sounds. That's the way it is. Information at its most basic level is bits. And bits at their most basic level is binary. A 1 and a 0. We all know computers work on 1 and 0s. Those are binary bits. Okay. Well, the way this works is we have 2 assumptions in this model. And that is what I'm telling you. My big toe is a model. It's a model of reality. All we ever can do is make models. And we start with kind of the first consciousness cell. So I'm talking now about the origins, the way consciousness may have started. The first consciousness cell, think of it as primordial consciousness. It's not consciousness like we have now. That evolved from this first cell. And all this first cell was, and this is an assumption that this exists, first assumption is consciousness exists. Well, that might sound like a cheat, but after all, we are here and we are conscious. So it's not that bad of an assumption that consciousness exists since we're here and we're conscious. And we can kind of wave our hands and come up with a little logic that shows why that might be true. Well, that first consciousness cell was just something that could tell that it could exist in either this state or that state. It was a 2-state thing, binary. That's all it could do. It's all the awareness it had. It said, oh, here I am, all alone, and I can be in this state or that state. That's all you need. If you've got that, then evolution can take that consciousness cell and evolve it. And now there's a this state, and that state, and this and that, and you have more and more 1s and 0s, and eventually this thing can evolve into the larger consciousness system. Okay, now, we have some logic that says how that might happen. That is, there's a new, couple of decades old mathematics that is called emergent complexity. And what the mathematicians have been able to do is show that if you have chaos, you have a lot of randomness, and if you wait long enough, sometimes some of that randomness will just happen to come together in a way that it makes something that isn't random. And sometimes that thing that isn't random will be able to persist. A lot of times it just then tears apart and goes back into being random again, but sometimes it will actually persist. And sometimes it not only persists, but it builds. And we couple that, so they just can show that statistically this has a finite probability of happening that way. Then you have cellular automata. Cellular automata, if you don't know about those, Google, I think it's Conway, Game of Life, and you'll find cellular automata. What that is it takes almost like a checkerboard. It takes boxes, and the very simple ones make boxes white or dark, black or white boxes. And then it makes a little rule. And it says, all right, if a black box gets surrounded by at least 3 white boxes, it'll turn white, and vice versa. If the white box gets surrounded by 3 black boxes, it'll turn black. So it does that to all those boxes that were there, and now it has something new. And then it does it again. Okay, with this new thing, let's apply the same rule. They get something new, and they keep doing that. Okay, that is a process where the output is fed back into the input, which produces a new output, which is fed back into the input, and you have this simple little process that does it. Well, they've played with this now for some years, and they have found that these cellular automata can do everything that a general purpose computer can do. In other words, they found simple processes that will generate patterns that can serve as logic gates, that can serve as ands and ors and other sorts of things, and serve as bits. It's amazing that they'll have things that duplicate, patterns that will duplicate themselves. They'll start a pattern like this, and then it disappears here and duplicates itself here, disappears, duplicates, and it looks like it's just flying off the side of the screen. They have those, and then they interact with other patterns. Some of their patterns, of course, just end up static. They change and change and change. They get to a point where they just don't change anymore, and they're static. But other ones that are more cleverly done, again, with very small little processes, not complicated processes, just little processes. Some of them have gone on and are still going on forever, and it seems like there is no end. They always generate new patterns, new things. There's always an output to feed into the input. So we have this capability of cellular automata to go on with its evolution. Now, it occurred to me, I don't think it's occurred to anybody else, but it's occurred to me that what we're looking at in these cellular automata is what I call a process fractal. Okay, we know that geometric fractals are little mathematical equations. Maybe it's a triangle or something, and then you put more triangles on all 3 sides of that triangle, and then you put even littler triangles on all the sides of all of those, which then some of them make bigger surfaces, and you put triangles on that, and you just keep repeating triangles upon triangles at different scales and sizes, and you can end up with these most amazing, complex pictures. And sometimes they look like natural things. They look like woods, and clouds, and streams, and mountains, and so on, which is now how most animators animate. Instead of drawing thousands of little pictures that are all different from each other, a lot of the animation these days is done in computers with fractals, because they can make things that look just like clouds in a sky floating over a mountain, and they can do it in a millisecond, whereas making all those little pictures is very labor intensive. So this is a process fractal instead of a geometric fractal. So instead of taking a geometric shape or a little geometric equation and letting it iterate on itself, you're taking a process. You're taking a process and let it iterate on itself. It's a process fractal. Well, it works the same way. If you have a little process, it changes and then it works on itself. You can build and build and build, and you can create the most complex, fantastical things out of just this little process. Same way that geometric fractals work, a process fractal. Okay, now, evolution is a process fractal. Evolution has an output, and then the input, evolution, works on that output, and then it works on that output. Evolution, look what evolution's built. Start with a cell, and you end up with all of this. You see, that's like a fractal, right? Well, this is a process fractal, a whole new concept of mathematics. Someday somebody will read what I write, and they'll think that's neat, and we'll have people doing process fractals, but not just yet. Anyway, biology has the same kind of, well, I shouldn't say just biology, but evolution. Biological evolution has the same kind of theory as this theory. It needs two assumptions as well. Now, my second assumption is that evolution exists. So consciousness exists, evolution exists. Or at least that first consciousness cell that could go this way and that way existed, and then evolution exists. For biology, it has to have that first biological cell. And then it can tell you how evolution can logically crank on that and produce all of this, and they can show you fossils, and they can explain all the facts that it shows, and it's exactly the same way. They need that first cell to work on, and they need evolution. I need that first consciousness cell, and I need evolution. So it's the same kind of thing. And if you look at the cosmology, look at the Big Bang. The Big Bang needs that ball of plasma that went bang. See, they have no idea where that came from, because our universe didn't exist yet. You see, our universe is what happened after that went bang, and the energy cooled and gravitation pulled things together, and we ended up with suns and planets. Oh, and I'm talking way too fast. Sorry guys back there, I get excited and I talk fast. They came up during the break and said, "You're talking too fast, I can't translate that fast." Here I am, going on a mile a minute. Anyhow, that's how biological evolution starts, is exactly the same pattern. Cosmology, the same pattern. You've got to start with an assumption. We have no idea where that ball of plasma came from, but given that, evolution will derive this universe. Well, then you find out that if you think about virtual reality, and you say, well, how would I know that I am in a virtual reality? One of the most obvious ways to tell is that in a virtual reality, things just start. They just happen. You see that elf in World of Warcraft. Make that elf a scientist elf, and he goes back in World of Warcraft and said, I want to know, when did this start? How did this World of Warcraft world start? And he goes back until a certain point, and he says, well, before that, there wasn't anything. And then there it was. It just started. Well, it started when somebody hit the run button, right? When you hit the run button, the algorithms start computing that virtual reality. So if you live in a virtual reality, you should expect things to just start. And that brings us up then to the Big Digital Bang. In the Big Digital Bang, it follows the Big Bang idea, except it's digital. It's a simulation. It has initial conditions. That's that ball of plasma. How hot is it? How big is it? How much pressure and temperature and so on. And it's got a rule set. Every virtual reality needs a rule set. That tells it how things interact. So you hit the run button, and that ball of plasma starts to expand because of the rule set. There's gravity, there's pressure, all those things that are in the rule set, called our science, our physics, stuff we know now and stuff we haven't figured out yet. That's the rule set. And eventually, in this simulation, you have us, you see, because it all just evolves. That's what it starts from. Now you look at these mysterious things like the expanding universe. Okay, physics say we have an expanding universe. It's not only expanding, it's accelerating. How could that happen? They even made up something like dark matter just to try to deal with that. Because the dark matter is what pushes it all away, because gravity's supposed to be pulling it all back together, you see, and here it is accelerating, and that's not right. So we invent something, call that a fudge factor, to give us the right answer. Okay, but they don't realize that this is the footprint, if you will, of a virtual reality. Because in a computer, how big a universe can you make in that little laptop over there? As big as you want, right? Take an equation for a sphere and let R, cube R, every iteration, every time it runs through the computer runs through the cycle, and pretty soon you'll have something that's a whole lot bigger in our universe. And can you make it accelerate? Sure, why not? You just add another little term to the equation. You see? So it's not so amazing that you have an expanding universe. Whereas under materialism, it's, well, what's it expanding into? You see, this physical universe is all the reality there is. If that's the case, what's it expanding into? What's out there that now we're going into it? And see, space. Where does space come from? And then you'll find out that physicists have a lot of these secrets of things they don't know. That double slit experiment's not the only secret that they don't talk about because it's embarrassing. They don't know where mass comes from. They don't know where charge comes from. They don't know where space comes from. They don't know where time comes from. They have no idea where gravity comes from. They have not a clue where spin comes from. These are all fundamental things. Now, they know how all these things interrelate, that's physics, but they don't know where they come from. They don't seem to come from anywhere. They just are. Charge just is. Well, an electron has charge, true. Well, they break that now into quarks, pieces that have charge. Well, where did that charge come from? You see, you can break it into pieces, but you still have the same problem of what is it? What is charge? How do you get charge? And there's no causal path. There's no causal path that leads from something to charge. Charge just is. Space just is. Time just is, you see? And that's not good science, just to say stuff is. If people say, well, this just is, scientists call that person a mystic. The basis of most physics, most physicists would want to shoot me for this, but is mysticism. At their root, a lot of stuff just is. And that Big Bang just Big Banged out of nothing. Because where did that plasma come from? You see, there's a lot of things. In biology, well, we just had that first cell. You see, everywhere we look, we see that things just kind of weren't, and then they were. Well, that mass, time, space, all that stuff's just part of the rule set. It's just the way things interrelate. It doesn't come from anywhere. It's part of the rule set. It doesn't have a causal path. But in a materialistic, objective universe, it should have a causal path. That's required. Don't tell anybody it doesn't have one. That's embarrassing. Okay. Information is non-physical and subjective. That'll take a lot of people by surprise. Information is non-physical. Okay? And if consciousness is information, then consciousness is non-physical. But we know that because we know the computer has to be an other, and the consciousness has to be an other because the consciousness has to talk to the computer. Now, you probably lost you there, but in World of Warcraft, you've got a world that's built up, a virtual world. Okay, the computer can't be in that world. It has to be outside the world. It has to be non-physical to the world. The consciousness can't be in that world either. That world's just computed. Consciousness doesn't live in a hard drive in a computer. The consciousness is the player. You see, that elf doesn't do anything, doesn't move, doesn't run, doesn't fight, doesn't do anything until the consciousness, the player, tells it to. The player says, run away, and then says, no, turn around, go back. Well, the consciousness talks to the computer, and the computer talks to the consciousness, and they send data back and forth. The player, with his computer and his joystick and his mouse, talks to the server that serves the World of Warcraft, and the server sends data back to him. The World of Warcraft itself is just data in a computer. Just virtual worlds, you see. All virtual worlds are just data in a computer. And so is our world. So is this body. So is all this stuff. It's just data in a computer. I know it's getting hard to understand now, right? But that's the way virtual worlds work. And the consciousness has to be in the same reality frame as the server. Because they communicate. You can't communicate directly between reality frames. You have to connect within the same reality frame. So the server has to be non-physical to the elf. So does the consciousness have to be non-physical to the elf, because they both are in that same other where they communicate. Okay? So now what does that say about us? That says that we are virtual. Everything we see here is virtual, and our consciousness lives in other. And our body is the character, just like the elf. And without that consciousness, we're just like the elf. We just stand there and don't do anything. The consciousness is getting the data from our senses, which are constrained by the rule set, right? And it interprets that data into this. Okay, now just a bunch of big steps there, you know, so maybe I'll get back to it a little later. Let's think on that a while. Okay, information is non-physical. Okay, now, so what do computers deal with? They're information machines, right? No, they're data machines. Okay, so it takes a consciousness to interpret information out of data. So that's the difference between data and information. Information's the meaning, it's the content, the message. It's not the media, it's not the code symbols. So I look at this paper and it's got a lot of little ink on it. That ink is the code symbols, you see? And my consciousness, which is in other, gets that data and has to interpret it and give it meaning and significance. Only a consciousness can do that. And if I communicate to you, I have to present what I want to communicate to you as data. The data goes over the system and comes out here in the speakers, and you have to take in that data through your ears and eyes and interpret it. But when you interpret it, you make information out of it. You see? So that's the difference between information. Information is non-physical. How much does information weigh? If you put a lot of information on a scale, what do you put on the other side to balance it? Oh, information doesn't have mass. Well, that's a good sign that it's not physical. How much information can you put in a bottle? You know, it doesn't have volume either. So it doesn't have mass, doesn't have volume, doesn't take up space. You know, how much information you put in a bottle before it's full, right? So it doesn't have any of the attributes of physical. It's non-physical. It's understanding, it's meaning, it's interpreted. It only can be created by consciousness out of data. But we pass data around between us, and then we have to do it. So each of us, think of the whole, if I kind of wind, taking a lot of time on this, but I'm probably talking about things that are on other slides, so we'll make it up later. If you think about this now, we have a computer, a server, and a consciousness. And the only thing goes on in virtual reality is that these two talk with each other. And as they talk with each other, the computer modifies what's going on in the virtual reality on its hard drive. You see, every time it runs through another delta T, it recomputes where everybody is. It's a multiplayer game. And the consciousness and the server have to be in the same reality frame. They can't be in separate realities. They have to be in the same. So that's the only two active components here. So we are consciousness. We're talking to a server, and we interpret the data to be this. Consciousness is non-physical. It's an information system. You see, the server is information system. The consciousness is an information system. They're both in other that are non-physical, and it turns out they're all part of the same thing. You have this one thing that's the larger consciousness system, and a piece of that larger consciousness system is the computer. Another piece of that large conscious system is you and I. You see? Now we get to say, we're all one. So that's how that falls out. You see, we're pieces, and I'll get a little bit. Now we're going to get to understanding what I've just said in kind of detail. Maybe when I say it the next time, I'll say it slower, guys. So So to convert code symbols into meaning, to grasp the information requires a consciousness. And understanding requires a subjective interpretation of the data, unique to the individual. So every one of us lives in our own reality. Yes, there's shared components, it's a multiplayer game, but everybody gets data, and everybody interprets that data based on their history, their knowledge, their fear, their ego, their love, everything else. You interpret it, and that's yours, that's personal. And that's your reality. So we all live in a reality that's subjective and personal to us, but because it's a multiplayer game, we share parts of it too, you see. All right, I'm gonna move a little quicker now. That was a lot, but I know I could see people's eyes starting to wobble with all of that. Okay, now information systems and evolution. Information in a digital system is represented by organized bits. Okay, information systems have entropy. It's a key idea here. Information systems evolve by lowering their entropy. Entropy is a measure of disorder. A lot of disorder, high entropy. Not much disorder, low entropy. In an information system, the ultimate in disorder is that every bit is random. No information. Okay? Now, as those bits are put together and you make constructs of something that have meaning and have significance, then you create information. And you've lowered the entropy of the system because now there's more order and less disorder. So see how all that works? So an information system evolves by lowering its entropy, creating content, creating information. And if it doesn't evolve, it will de-evolve. And that's just the way of things. If you don't work, if you don't do maintenance on your house, eventually your house will fall down. You have to continually put energy into something to maintain it. Things just don't maintain themselves for no effort. Maintenance requires effort. So you have this larger consciousness system, and it's a self-changing system with a purpose, and its purpose is to survive. Its purpose is to evolve, okay? And it does that by lowering its entropy. Okay, so large, complex, self-changing information systems evolve by lowering their entropy. Okay, and consciousness is a self-aware, self-modifying system evolving toward lower entropy states. Okay, now we'll see in a minute just what that means. What that means is if you have this monolithic system, and it's just your larger consciousness system, and it's evolving, and it's just one big system, like I said, this way, that way, lots of ones and zeros, it needs to lower its entropy, otherwise its entropy will go up. It'll be more and more random, and eventually it'll be nothing but random bits, and that means it's dead. It's no longer a larger consciousness system. It's just a dead random thing in chaos. So it has to lower its entropy, and it has to continually work at it. Well, how would it go about doing that? It needs more order, more complexity, more structure, more interaction. The natural path is that it breaks itself into pieces that interact with each other, and that interaction has to be with free will. Any other interaction doesn't do it any good. It's not getting any novelty. It's not lowering its entropy if it's just all, if it's all just a plan. So it has to have free will to interact with itself, and that then creates a lot of novelty, because it's not only just this one thing and what it's thinking and doing, but there's all these other things interacting with free will. And some of these things will maybe evolve and some will de-evolve, and you know how it is, you got a lot of things together and they all have a different opinion of the way things are, and all that difference of opinion creates structure, cooperation. Okay, now, so that's where we come from. We come from this larger consciousness system needing to evolve, breaking itself into pieces to interact with itself. Look at biology. It's the same way. We had this one cell, nifty, one cell. What can we do with one cell? Well, we can do the bacteria thing. We can maybe do the amoeba thing, but to really get creative and lower the entropy of the biological system, we have to cooperate with other cells, and we make a multi-celled thing. And now that we got a multi-celled thing, the multi-celled thing then starts to specialize. Now here's the cells for locomotion, here's the cells for control, here's the cells for biting and fighting, here's the cells for different things. They all have different functions. And now here we are as people, and we got trillions of cells, all sorts of groups, thousands of different specialized cells that do special things in our body, and they're all cooperating to do this together, to make something bigger, more survivable, more order, more structure, less entropy, and therefore, better things. And this process fractal called evolution, if the stuff doesn't work that gets done, goes away. The stuff that does work, according to the rule set, grows on. That's how the fractal works. Okay, so that's why we are here. Now, take one further step. We're here, and we're interacting. And the system has done this to lower its entropy. All right, now how do you best lower entropy if you have a social system of chunks of aware consciousness interacting with each other? Okay, let me give you two opposites, and we'll see how those two might fare. One of them is they could interact with love, with caring, with cooperation. Okay, start with 10,000 units of consciousness and an environment with a certain amount of resources, and then let this be the love group, and let them go cooperate and interact with each other. Love means it's about other, not about self. You do things for other. Self is not at the center. Okay, now let's get the other group. We'll call that fear, because fear is the opposite of love. And in the fear group, we're going to give them the same 10,000, the same resources, the same environment, and we're going to let them go and see what happens. Well, in fear, there's no cooperation, there's no trust. It's everybody trying to get whatever they can get, and then trying to figure out, once they've got it, how to keep it. Okay, well, what does that do? Well, eventually, after lots and lots of fighting and struggling to get and to keep, you'll have groups of those that will kind of get together and say, look, let's all hang together and help each other keep what we got and get more. And then other groups will form to do the same thing, and then those two groups can fight with each other, right, and have wars and so on. And if somebody comes up with a good idea, well, they keep it to themselves, because otherwise it'll be taken away. If somebody builds up something and creates something nice, well, if somebody else is stronger, they'll take it. They'll take it away. You see? So that fear group is constantly high entropy. Somebody tries to build something and it gets torn back down. Things are not shared. Value is held close. That's the greed group. See, that's the ego group. So now look at those two and say, which one's better at lowering entropy? Which one's better at building, you see, and making structure and creating? Well, it's obvious, it's the love group. All right, so now how does consciousness, this digital information system, how does it evolve? What's its path to evolution? And what's its path to randomness and destruction? Love is how it evolves. So this larger consciousness system evolves toward becoming love, because that's how it survives. And it can't just stand still. Standing still starts to come apart at the edges. So it always has to do that. So now, why are we here? What is our job? We as individuated units of consciousness, pieces of this thing, we're to become love. We're to understand that cooperation is better than selfishness. We're to understand, if we work together, that we can do more. So this reality, why is this virtual reality here? It's a learning lab. It's a trainer, if you will. We come here and we've got this job to grow up. And we have to do that by making choices. So we make choices. Things happen, we make choices, and we get feedback. That's why you need a virtual reality. If you didn't have a virtual reality, the feedback is very difficult. Imagine, no virtual reality, just a bunch of individuated units of consciousness. It's like 100,000 people in a chat room where there's no rules. Where's the traction? You can't, it's hard to learn from that, because you can't take anything at face value. You know, everything could be different than it seems because there's really no feedback. What a virtual reality is, it's a rule set. That's all you need for a virtual reality. It's just a rule set. Any game, this is a game, any game only exists because of its rules. If we all get together and say, let's play a game, all right, start. You know, nobody knows what to do because there aren't any rules. It's the rules that create the constraints that make the game interesting, that create structures that you can tell whether you're winning or losing, or whether you're doing it right or doing it wrong. It's the rules that make it a game. So here we are, and we're pieces of consciousness. Our purpose is to grow up through the choices we make. We're in a virtual reality, which I could call an entropy reduction trainer for individuated units of consciousness, and we have now a purpose. You see, all of this is basically logical deduction from our two assumptions, which are evolution exists and fundamental consciousness exists. The rest of it all just kind of falls out as the way virtual realities are. It's the nature of a virtual reality that the consciousness and the computer have to be in the same reality. They both have to be non-physical. So all of this is pretty much deductive. So now we have defined morality. We know what good and bad is. Good is what leads toward entropy reduction. Bad is what leads to entropy increase. We have morality. And morality then is not based on action, it's based on intent. Okay. So let's try to go through these a little more quickly. All right, so we've already done this. To produce an effective, profitable interaction, you need two things. Goal, that's the purpose, the lower entropy, and you need constraints. That's the game. That's the feedback. That's the interaction. Okay, and you can see there that our local physical reality is an elementary school. You probably thought it was graduate school or college, but it's an elementary school. Maybe even a daycare. A virtual reality entropy reduction trainer for individuated units of consciousness. All right. Now, all realities where you can experience, all experiential realities are virtual. Because if there's no rule set, there's no interaction defined. Right? There's no context for interaction if there's no rule set. So every reality is a virtual reality. So it's not just this universe. When you dream, that's a different virtual reality. When you die, you end up in another virtual reality. You see, they're all virtual realities. The first virtual reality was just simple communication protocols, ways that these individuated units of consciousness could communicate with each other. That's the first virtual reality. It's just rules that allow them to communicate. And after that, of course, evolution gets it, bigger and better, stronger, faster, more complicated, lower entropy. Okay, so we'll slide on through. Did it work? Yeah. All right. Okay, now let's talk about the attributes of consciousness. We've already talked about moving toward lower entropy. Love is the nature of a low entropy consciousness. Now there you have it, a technical definition of love. It's the nature of a low entropy consciousness. That's what love is. Now, when I talk about growing toward becoming love, I also could use the words spiritual growth, increasing the quality of your consciousness. You see, there's lots of other ways that you can say this. Growing up, all of those things indicate the same sort of thing. All right, look at consciousness. It's sentient, self-aware, able to learn. It has input. If you have consciousness, there has to be input. It has memory. If you didn't have memory, every input would be your first. It has to have processing. It has to be able to judge the data it gets against the memory that it has to make sense of what it's getting. And it has to have purpose. It has to have some reason, because otherwise, how would it judge whether it's going in the right direction or wrong direction? That's the only thing that gives it stability or direction is its purpose. Okay. The larger consciousness system's purpose is evolve or die. You know, that's its thing. It's got to be self-modifying and self-improving. Notice the exact same attributes of living cells. Living cells have all the same attributes, the same parts. Okay. All right. Now, we'll talk about virtual reality. Virtual, of course, means informational, computed. And when you talk about a virtual reality, it's relative to the actual reality, which is where the computer and the consciousness is. So the virtual reality is a derivative of the larger consciousness system, as is the individuated unit of consciousness, and as is the server. These are all derivatives of that larger consciousness system. Right. Okay, now the nature of virtual reality. I'm going to twist your brains a little bit again. Do we need to have oxygen in this room in order to sit here and breathe? Most everybody would say, yeah. If we didn't have any oxygen in the room, we'd all fall over dead from asphyxiation. No oxygen. But we really don't need oxygen, because virtual realities are about, it's about the effect, not about the source. It's a top-down reality, not a bottoms-up reality. So we continue to sit in here and breathe and stay awake because it's probable that we have oxygen here. Why is it probable? Well, because there's trees and there's plankton in the ocean and all the things that do that. There's doors and windows and air conditioning systems that put fresh air in. And all of that stuff makes it probable for us to do fine. The only oxygen we need in this room is if some scientist or chemist does something to look at oxygen. So if he takes his microscope and he looks at an oxygen molecule, there it is. And that oxygen molecule gets rendered. Okay, now we're talking about rendering. Remember, we're all individuated units of consciousness getting a data stream from the computer. We all get our own independent data stream. Why would a computer send us a data stream with oxygen in it? We can't do anything with that. We don't work at a molecular level. It sends us this data. And it allows us to stay in here and breathe because there probably is oxygen in the room. You see? It's all a matter of probability. So the reality actually is implemented probabilistically. This simulation is not a deterministic simulation. It's a probabilistic simulation. Well, that shouldn't be surprising. Why are particles probability distributions? This is a probabilistic reality. Okay, so we get a data stream, and now people get confused. They say, well, does that, and that defines our reality. So right now, I'm getting a data stream that shows me all of your faces out there wondering, what is this guy talking about? And you're getting a data stream that sees me, but you're seeing his background. And now I don't have that background in my data stream. Now if I turn around, I do, but then I don't. Same with your elf. Your elf in World of Warcraft, if he looks to the left, he sees the lake. He looks to the right, he sees the mountains. It's the data in the data stream that comes up on that monitor that you interpret, that in consciousness interprets as that reality. So you get in your data stream the information that shows you what you're sensing at the moment. Okay, so then people say, well, okay, I live in a small town and everybody goes to bed early. Does that mean when everybody goes to bed, the statue in the park in the middle disappears? No, that statue in the park was never there in the first place. You see, it's just data in a computer. When you get up and look, now you get the data in your data stream and you see it. If nobody's looking at it, why would the computer just continue to send out data, and to who would it send it? See, there's nobody to send it to. When all the players are gone from World of Warcraft, does that computer just keep on making those rocks and those rivers and those creatures just because it likes to and it's fun? No. When a player logs in, that player gets a data stream. And wherever that elf looks, it's in the data stream. You see? We're the same way. So it's not when we turn our backs, things disappear. It's that they were never there in the first place. It's just a data stream that we interpret as this. So that's the same with the oxygen. Everything is based on probability. Now you set up a camera to look at that monument or that statue in the middle of the park of the small town, and that camera is just an extension of somebody else's eyes, right? So that camera will continue to see it. It'll continue to get the data stream. It'll continue to, make the film show what's there all night long while everybody else is asleep. Because otherwise it would create a big discontinuity, a big inconsistency in our reality. And if this is a good virtual reality, we don't want inconsistencies. And that brings us to this fundamental point that I've got in orange here, and that is when something is rendered, it must be consistent both historically with existing data and causally with the rule set. Okay? It has to appear that this virtual reality is continuous and without mismatch. It all has to be a smooth reality. And that happens well in the World of Warcraft. You have all these people, thousands of players are in there at the same time, and they fight with each other, and they talk to each other, they hang out together, they do all kinds of things, and a computer keeps up with all that interaction. That's not all that hard. So here's another one that might be fun. We've all heard this thing. If a tree falls in the woods and nobody's there to hear it, does it make a sound? Well, the actual solution to this is there is no tree, there is no woods, there is no sound. It's all virtual reality. And here I'm going to tie it back into quantum mechanics. So we have a person who walks into a woods that nobody's ever walked into before, virgin woods somewhere, imagine that. And they walk into this woods, and what they see is a dead tree, and the dead tree looks like it's about to fall over. It's wobbling around when the wind blows, but this is a dead tree and it's standing up, okay? Now, they leave the woods, maybe they take a picture of that tree, they leave the woods, and they come back, say, a year later. When they come back a year later, they see the tree lying down on the ground. Now, they will assume that the tree fell over. But actually, what happened was when they walked into the woods, there was a probability distribution of what they might see. And this probability took into things like what part of the world they were in, what was their altitudes, what grows here, and so on, what would likely be in that woods. And there was this probability of what they might see. And they take a random draw from that probability distribution, and that's what they see. And there was that dead tree, a random draw from a probability distribution. This is how the virtual reality is done. It's a probabilistic reality, not a grounds up, little particles make bigger particles that make bigger particles that make molecules that make the stuff. It's a top down. So he sees that wobbling tree. Okay, now once he's seen that wobbling tree, just like the particle, once that particle's measured, that wobbling tree stays there. The next guy walks in 2 minutes later, he'll see the same tree because now that has been manifested here, so the tree's still there. Okay, so the tree didn't fall down. What happened was a year later, he walks into the woods, and the probability is that that dead tree that was so wobbly with all the probable wind and the probable, critters or whatever else, the probability was higher that it will be lying on the ground. So when he walks back in, the tree's lying on the ground. The tree never fell over. It just was, this was probable, then that was probable, you see? So that's the way it works. Now let's say he goes into the woods the first time, he sees the dead tree, he takes the picture of it, he walks out of the woods and meets a great big grizzly bear that eats him and his camera. They're gone. Gone. Information's just been destroyed. It's just gone. Now, bear walks off. A few minutes later, another guy comes up with a camera. He walks into that woods. Will he see that same tree? Not necessarily. He might, Because he also is walking into a tree. There's no information here that says whether there's a tree there or not. He takes a random draw from a very similar probability distribution. There wouldn't be much change in a few minutes. A very similar distribution, and there may or may not be a dead tree there. You see? There's no inconsistency in the reality at all. He believes that it's always been that way, the way he sees it. You see? So we've just seen information being destroyed. That's the same in a double slit experiment, where we have the data, and we erase the data, and when we erase the data, we have to go back and draw a new, a new result, which comes out of the probability. So the whole world works like that. Now, let's imagine an astronomer. An astronomer is going to point his newfangled telescope that's better than any telescope's been before, and he's going to point it out in this sector of space. And what happens? Well, there's a probability distribution that maybe 1,000 different things could be there in that sector of space. It just depends, what's around, it just depends on the probability. So he gets a random distribution from that probability of what might be there, from what's possible. See, there's a lot of things that are possible, and some of them are more probable than the others, and that forms a probability distribution of all the possibilities and the probability that they could be there. And he draws one thing out, and that's what's there. He makes a picture, he publishes it, and everybody that looks there will find that thing that he found. Now, they may get better resolution, they'll dig in deeper, they'll get more information, and then that will become reality too. So you see, it's not quantum mechanics. The way it works isn't just for little things, which always bothered me when I was a graduate student. Why is this science just for little things? That didn't ring true to me. The science of little things. It seemed to me that if it was a general true principle, it had to be a general true principle, and indeed it is. The same thing that creates the quantum mechanical problems creates the problems for the astrophysicist, and that is uncertainty. You see, nobody knows up there. There's lots of uncertainty. And where there's lots of uncertainty, there's lots of possibilities, and they have different probabilities. And you get to pick one. But also, now if you have a ball, and I drop a ball, and we say, well, how long will it take to hit the floor? Well, there's not much uncertainty there. That can be calculated to 6 decimal places. And the only uncertainty will be in that 7th decimal place. 7th decimal place. That's where the uncertainty is, and that's all that basically your probability distribution has to all be down in that 7th decimal place, you see? So it looks like it's objective. It looks like hard science because the uncertainty is small. When the uncertainty is big, like in photons and electrons and little things zipping around at high speeds, well, there's lots of uncertainty. That's why we get double slit experiment effects. We get that same thing here, and you can see now while physics is a subset of this bigger picture where the uncertainty is small. Now we know this is a fact by a lot of our experiments. We know the placebo effect. The placebo effect is an effect that if someone is told, this pill is a new wonderful pill, we've tested it, it's great, and if you take this pill, your liver will feel better. But it's just a placebo, it's just sugar or sawdust or something in that pill. But 35–40% of the people who take it, their livers will get better. And it's not just that they think they will get better, it's not that you're tricking them by lying to them. Their livers actually get better compared to a control group that wasn't told anything. They were said, take this medicine. That's the control group. The ones that were given the positive intent, they get better. Now, that's why should that happen? What's the materialistic explanation for that? Well, there is none. A materialist would say this body is a machine, and it does what it does, according to the laws of biology, and that's just it. No matter what somebody goes yammer, yammer, yammer in your ear isn't going to affect what this body does because it's just a deterministic machine. But we know the placebo effect does work. Indeed, it works so well that in order to sell a medicine, drug companies have to show that it's more effective than the placebo. More effective than just telling people that they'll get better. And you know what? They have a hard time beating that placebo effect. It's a very powerful effect. And drug companies are having more and more trouble as they go on doing that. And the reason they're having more and more trouble is that we're jaded. We've heard it all. Yeah, right. Great new pill is going to make me better. Huh. You know, we don't believe it. So we don't take that positive intent, and it doesn't help us much. So the drug companies are getting desperate trying to beat this placebo effect so they can sell their drugs. And what they have done, they go offshore. They go to some more naive population, do their study there, prove that it beats the placebo effect, and bring it back here and market it. The law doesn't require them to do it here in the market in which they sell. It just requires them to do it because in the idea of science, the way science looks at it, it doesn't matter. Any population's the same. They're all these biological machines, and they all work the same. So if it works for these people, it works for those people. Of course, the drug companies know that's not the case. That's why they go elsewhere to do their drug research, someplace where the people are more naive and believe what they're told. And our culture's become real resistant to that sort of thing, because we believe very little of what we hear anymore. 100 years ago, we believed almost everything we heard from authorities, and now we believe almost nothing if an authority says it. You know, we've turned around the other way. So that's how that works. At night, we look up at the stars. Does that mean that the system has to produce the physics of all those gas clouds and, you know, suns and all that nuclear physics and particles and pressures and all? No, light's in the sky, right? You look up and you see a point of light. That's all you need to see. The system doesn't have to calculate all that stuff just so you can see a light in the sky. That's inefficient. That's bad programming. That's bad computer science to compute all this junk just to produce a light in the sky. So all you see is a light. Now you look with a telescope, now you get to see more resolution. So now the system gives you more resolution in your data. Then you send up a probe that goes there and takes a close-up, then you get more resolution in your data, just like here with the oxygen. No point to make oxygen here. We breathe because it's probable. We only need oxygen if we look at the molecule. Then we have to have oxygen, or if we need it in a chemical reaction, then it has to be there. Okay. It's the same way in World of Warcraft. We work just that way, except we're evolved, we're not programmed. Okay, we've done the tree in the woods. Oh, and somebody will always ask me, well, that thing about the tree in the woods, what if there were squirrels living in that tree? And that's a good question. What about those squirrels? Well, I'm talking about consciousness. Consciousness is not exclusive to human beings. Consciousness is widely spread in the way it's, you know, evolved. Process fractals evolve. Anything, you know, if there's a space for it, you know, it'll evolve there. You know, that's the way the fractal processes work. So that squirrel that was in that tree, now he has also a data stream. That squirrel gets a data stream. It's not like our data stream. He doesn't see a tree the same way we see a tree. He sees a tree the way a squirrel sees a tree. And he gets a data stream like a squirrel would get a data stream. Squirrel's data is different than ours. And it gets that data stream. And if that squirrel happens to have a nest in that tree, then, and that tree falls down and that squirrel happens to be in it, well, then that squirrel experiences the whole thing, right? Because the consciousness is there. It's like if the man was there while the tree fell over and had his movie camera and took a picture of the tree falling over. Well, critters have consciousness. Dogs and cats and squirrels and mice and bumblebees. You know, it's not just people. And they're all doing the same thing. They're all making choices, and they're all evolving or de-evolving based on their choices. They just have a much smaller decision space. The decision space is how many choices do you know of? Okay, here's a choice. Somebody comes up and says something rude to me. I have a choice. I can get angry. I can be upset but hide it. I can ask them if there's anything I can do to help. I have all these different choices the way I react to it. But what I do, what most people would do, they'd get angry and then they'd say that he made me do that. He made me get angry. Well, he doesn't make you get angry. You choose to be angry. You have to take responsibility for all the choices you make. You have multiple choices. But the more you grow, the more you evolve, the more you become love, the bigger your decision space gets. The bigger reality you live in. The more decisions you have, the more responsibility you have. So that's really what it's all about. That's why I started saying this is not really about out of body. This is about being. It's about who we are and what we are and how we function. So what are we? We are data sets in a larger consciousness system. And we are playing in this particular virtual reality to gain experience and evolve. And why would we be doing that? Because as we evolve, the system evolves. The system is us. See, we're just pieces of the system. So as we lower entropy a little bit, the system's entropy is lowered a little bit because we're a piece of the system. So we are here as a strategy for the larger conscious system to not die, to not go random, see, to keep evolving. So we have a purpose. And one of the things that we get in this purpose, one of the feedbacks we get to help us with this purpose is we get to modify our reality. We get feedback. We get feedback in many ways. One way is our intention changes future probability. Okay, that's one of our feedbacks. And what that means is this reality, if you look at it, watch the news, and you think it's a horrible place where we live in, it's because that's us. We, the people, make it that way. We, the people, produce that because we modify future probability with our intent. And the way to make this reality better is not to go out and change things on the outside. Oh, that guy's a terrible, dictator. Let's get him out of there and put somebody else in. That's not how you change the world. You change the world by changing yourself. You change the world by becoming love. You change the world by making better choices. And if you do that, that'll spread to the people around you. You'll influence them because we're all, as consciousness, netted. We're all connected as consciousness. We all communicate with each other. Not physically, not body language, but we're all connected. When we all get together, we form kind of a group consciousness. That's why mobs are worse than any of the individuals are in the mobs individually. And that's why people feel better when they're around people who are very loving. Everybody kind of feels a little lighter and a little better around those people. Well, we create our reality. And we create it also because of the way we interact. When I'm hostile and I interact with you, then it makes you feel hostile. When you interact with somebody else and you see that it spreads, well, so does love. Spreads the same way. So we have kind of a group mind. That's why Carl Jung found these group, what do you call those? Archetypes. He found these archetypes that were cultural, species-wide. Well, there's archetypes down even into small social levels. There's an archetype that fits IBM. There's the culture that's in there creates kind of an archetype. Well, what it is all the people that feel like they're a part of that culture, kind of their minds make this archetype together. That's their culture. That's how cultures affect us. They don't affect us because somebody teaches us how to act in our culture. We absorb that. It's just there. We learn it just because we're here. That's the same thing that creates, what was it some years back where there were hundreds of people standing in line at 4 o'clock in the morning to buy a Beanie Baby. That's a fad. You know, why fads happen, and suddenly everybody has to do something that's kind of silly, doesn't necessarily make sense. You know, have this kind of clothes or hula hoop or something that they do because it becomes a fad, and everybody just has a need to go do it too. Well, that's because of you know, that's like the archetypes. That's our groupthink, if you will, because we're all connected. All right, the way the structure of this larger consciousness system is such that in order to have a good simulation here, it has to keep track of what's likely to happen so it can get ready to simulate what it needs to simulate. So it keeps track of all the possibilities and the probability that those possibilities will happen. And that's what I call the future probable database. And then we make all our decisions in the present. The present is where all the action is. We make choices in the present. We do this instead of that, okay? And as we do that, those probabilities collapse into a reality, okay, as we make our choices. Then, after that moment goes by, that then becomes history. And you have this historical database, which is all the things that could have happened and the probability that they would have. So these are databases. And these databases are available for us as consciousness to access. Because we're consciousness. We can get around in that larger consciousness system. We can't get outside of it because we're consciousness. But we can get those databases. Well, what's in those databases? Well, all the probable future, we affect that with our intent. Okay, you've ever done things like you go to a busy place where there's hard to find parking place, and before you leave, you get your intent. You say, I'm going to find a parking place. There's going to be a parking place just open up for me just as I get there, because if it opened up 30 seconds before you got there, somebody else would get it. It's just going to open up when I go by. And if you keep that intent focused, particularly if you know how to clear your mind of noise, it's amazing how often it works. That's intent, modifying reality. That's how healing works. You intend that the person gets well or things change. That's how healing works. Dr. Emoto freezes ice crystals. You've probably seen that on the web. He freezes ice, and as the ice freezes, he has happy thoughts or he has unhappy thoughts. He plays happy music or he plays awful music. And the crystals will be nice and pretty crystals, or they'll be ugly, smushy crystals, depending on what he thinks. Well, why is that? Because there's so much uncertainty in the way ice forms. You've heard there's no two snowflakes look alike. It's because there's a zillion ways for ice to crystallize. So there's lots of uncertainty. Where there's lots of uncertainty, you can affect it. You can affect it with your intent. Now, what your intent does is modify future probability. Doesn't mean you'll get everything you intend. There's other things going on besides you in this universe, but it just changes the probability. So if the probability was 1 in a million, and you use your intent and you're good at it, and you make it all the way down to only 1 in 100, you still probably won't get it. But you've had a major effect, you see. You've moved it from 1 in a million to 1 in 100, but it's only 1 in 5, and you have your intent, you know, and you make it to where it's 0.9 or 0.95, well then you encourage that to happen. So that's just one of our feedbacks in the way our reality works. So we are in these databases. People get inspiration and intuition out of these databases. People investigate past lives in the history databases. But if they don't know what they're doing, they'll get in something that was probable but not actually happened. That's easy too. But it doesn't mean that these past lives are alive and still functioning. It's just data in a database, just like data in a book. Except the database is so neat that you can go there and it's like being in the movie. And you can change things. You can go to that past database and say, well, instead of saying this, I'm going to say that. And what could the changes that'll happen in probability if you'd said this instead of that? And you can follow that on. But you're not changing anything other than you are querying a database with variables. Still is just the same data. When you're done with that change, everything is just the way it was because it's just data, you see. So There's a lot of things like that now that fell into the paranormal area that now fall into the normal area. It's just normal. We understand how that works. It, you know, it falls out easily. Things like, what's the word, synchronicity. You all know what synchronicity is? That's when things just happen to you that just happen to be right at just the right time. And you know, you walk into the bookstore and this book seems to jump off the shelf into your hands, and you look at it and it's something you really need to read, or something like that. You just meet the right person, and it happens enough that you know it's not just randomness, because if this happens to you a lot, your whole life is that way. If you live as love, if you live without control, without trying to control things, if you're that way, life just tends to give you what you need as you need it. It works that way. You see? Why the synchronicity? Well, there's a couple of reasons. One, your intent, your positive thoughts. The other is that the system wants you to succeed, because your success is its success. And if what you need is what's in that book, then indeed that book might jump into your hands or draw your eyeballs to it, and you'll look at it and you'll have this inclination to go pick it up and see what it's about. So synchronicity can happen when there's enough uncertainty to make room for it. You see, where there's uncertainty, there's flexibility in the system and flexibility for your intent. So that explains how synchronicity works. I'm just glossing over a lot of things because I see my time is running out and I need to end, but there's lots of more things we could talk about. And we will, Friday, Saturday, and Sunday, talk about them. Okay. You know, people talk to their plants. It's not because their plants listen to them and speak their language. It's because their positive intent for the plant creates a better plant. And there's other people that don't like their plants, and they have the brown thumb, and they don't work out so well. You know, you've heard of the power of positive thinking, right? People who are upbeat, happy, and very positive about life tend to have very positive lives. And people who are miserable and unhappy tend to have miserable and unhappy lives because they're creating that environment with their intent. Prayer. Well, prayer is just another way of focusing intent, right? So prayer can work. Now, if what you're calling prayer is all about you, and it's all about ego and fear, you know, what was that Janis Joplin song, "Dear God, please send me a Mercedes Benz"? You know, that is not likely to, you know, be answered, because that's just feeding your ego, which is counterproductive to the system. That's more fear. So intent directly influences probability. You create your own reality through, one, your limitations. You have to interpret the data. And if your interpretation is very limited because you have beliefs just make it more difficult for you to interpret things well. Beliefs just shut you off because you no longer are open to things. So it's limitations. If you have fears, you'll interpret things differently. So you create your own reality through limitations, through interpretations, through interactions. If you act real nice to people, they will be inclined to act nice to you. If you use people and abuse people, they will tend to not act nice to you. So there's lots of ways you create your own reality. And of course you modify future probability. All right, we've talked about most of that. Now some of you will think, well, yeah, but you know, this physical reality does seem to have an effect. What if I get hit on the head with a pipe and I have brain damage? And then when I walk, I have to drag my right foot because that part of my brain that controls that leg, you know, it doesn't work anymore. Doesn't that prove that it's, you know, the brain is a physical brain that's controlling the body? No. The brain doesn't store anything, doesn't process anything, doesn't do anything. The brain's a virtual brain in a virtual body. Okay? All the thinking and the processing and the memory all is in the consciousness, which is in other, the non-physical. It's just a virtual body with a virtual brain. Well, why do I have to drag my leg? Because when I get hit with that pipe on the head, it changes the constraints. Now the rule set says I have a dent in my head and that part of my brain has been bashed in, therefore I can't control this leg very well. These are rule sets, science, biology, and physics. So the constraints change. Same thing happens in World of Warcraft. Your elf falls off a cliff, he loses hit points, he loses vitality. You know, there's an effect to that. The rule set says that, you know, you have to deal with that happen. If your elf stays underwater too long, it'll drown. Not because your elf has to breathe oxygen. It's because the rule set says if you stay underwater too long, you'll drown. You see? So we work the same way. So consciousness delivers feedback that forces us to deal with the consequences of being ourselves and to deliver ego-reducing growth opportunities. That's choices. That's why we're here. All right. Now, synchronicity, we've talked about that. Key there is weak history gives the system fewer constraints. Weak history means more uncertainty. The more uncertainty there is, the fewer constraints there are. Okay, we won't talk too much about that. Let's go to near the end. Growing up and becoming a part of the larger conscious system. We touched on this, but I'd like to kind of say a little more about it for a few minutes. And that is, the key here is eliminating fear. And a lot of times people say, well, how do I do that? Because these are fears that you don't even know you have. These aren't fears that you know you have. It's not like fears of being eaten by a bear when you walk in the woods. These are fears of not being right, fears of failure, fear of not being lovable, fear of being inadequate. It's these kinds of fears. Fear of not being liked. These fears create ego. Ego is a product of fear. If there's no fear, you don't need ego. And if you have no fear and no ego, well, also beliefs are a product of fear, mostly the fear of the unknown. We believe things because they're important and we don't have the answer, so we just believe something because believing something's better than dealing with the uncertainty. So if we get rid of the fear, the beliefs, the ego, expectations, all that stuff drops away, and what's left? Love. You see, so you don't have to go out and do something special to become love, other than get rid of the stuff that's in the way, which is the fear. How do you eliminate the fear? Well, the best way is look for the ego. Ego's easy to spot. Fear is hard to spot because we deny most of our fears. Even if faced eyeball to eyeball with somebody telling us that, we deny most of our fears. But the ego's simple. All you have to do is, whenever you feel something negative, when you're upset, when you're angry, when you're, have anxiety, all of those things, that's ego. If you didn't have the ego and the fear, you wouldn't feel those negative things. So when you feel something negative, ask, where did that come from? What fear had me feel that way? Okay, so somebody steps on my toe and I get angry. I should say, why did I choose to be angry? The guy was just clumsy, or maybe he wasn't clumsy, maybe he was being rude. But that's my choice. So why do I choose to get angry? Well, because nobody pushes me around. That's why. Because that so-and-so, should watch where he was going. And all of that is what? It's about me, right? I'm at the center. If it's about me, well, because I didn't like it. And I shouldn't have to put up with that. And I, deserve better. And I should have respect. And it's all about I. You see, it's you at the center of your universe. And that's ego. And that comes from fear. Well, the fear is all the opposites of those things. I'm not so sure I'm so deserving. I'm not so sure that, people ought to really like me and be careful not to step on my toes and things like that. I'm not so sure. And because of the fears, if I don't fight back, I'll be overrun. If I don't push back, you know, I won't have anything left. Everybody will take all my stuff and I'll be left without much. So it's fear. The ego is easy to see. Anything negative in your emotions and your feelings and your mind is tied to a fear. Find the fear, and when you find the fear, let go of it. Now that's easy to say and hard to do. But if you work at it consistently, once you name the fear and you just let go of it, how do you let go of it? You accept it. You say, okay, I am incompetent. I am not lovable. I'll just accept that's the way I am, and I'll deal with that. I'll just go through my life and I'll deal with that fact, and I'll try maybe to do better, but I accept that. Once you accept it, it has no teeth. Fear can't bite anymore because you've accepted it instead of being afraid of it. And then what you'll find out is the fear was nothing but smoke. It's not real. These fears are almost always just in our perception. They're not real things. You fear that nobody will like you. People like you just fine. You're just afraid that they won't like you. You see, it's that sort of thing. So once you have the courage, the only antidote for fear is courage. Once you have the courage to just accept it and be authentic, just be who you are, then you have a chance to let the fear go. And when you let the fear go, it'll be like this big weight come off your shoulders because you're no longer carrying that around anymore. And you will be a happier, nicer person. That you will like yourself better, and so will everybody else. So that's the key. That's how you become love, is one fear at a time. And it's not easy, but if you're persistent, it'll work. And as it works, you will be a different person, because the change has to happen at the being level. We exist at two levels, at the intellectual level and at the being level. The change has to happen at the being level. If it happens only at the intellectual level, then you're acting better, but you're not necessarily being better. If you help the little old lady across the street because you think it would be the right thing to do, and besides people are watching you and they'd really think you were a nice person for doing it, it's the wrong reason. You help that little old lady across the street because you see her and she needs help. And you don't have to think about it, should I do it or not? You just do it because you do it, because it's at the being level. It's you, it's how you are. So you can memorize everything that are in my books about reality and whatever, but if you don't internalize any of it at the being level, then you'll make interesting cocktail chatter, but it won't really help you become any better than you are. It won't help you grow up. So that's just some keys of, kind of do the theory. I like to do a little bit. How do you apply it? What's it have to do with your life? And these ideas are life-changing in the sense that if you apply them, you really become a different person altogether. And the last thing is what I started out with, and that is, if it's not your experience, it's not your truth. So don't believe anything that I've told you. But be open-minded that it might be true, and that you are committed to find out. See if it works. You see, that would be my best hope. Not that you walk out of here believing everything that I say, because that really isn't going to help you. That's at the intellect, you see. The intellect is not where progress is made. It's made at the level of being. You have to be different, not think different. Now, thinking different can be the on-ramp to being different. It can help you be different, but it doesn't actually get you there. It just points you in the right direction. Well, that's it. I've gone fast. I've probably tormented my translators. And there's so much more to tell. This 2.5 hours almost is nothing compared to the 3 days that we got coming in a lot more detail. So I know there are a lot of logical holes here because I just had to jump and state things rather than derive them. But that's the way it is in a short talk. So if I've done nothing more than keep you awake, I guess that's good. If I've made you want to go, if I've made you want to go find out more, or learn how to heal somebody with your mind, or find your fears and get rid of them or something, then I'm really thrilled, because that's the whole point of it all. So that's where I'll leave you. Thank you very much.